configuration of 8+1 metering can indeed be implemented within a 400 amp panel. This setup involves the utilization of 8 submeters alongside one main meter, all operating within the capacity of a 400 amp electrical panel. Firstly, the 8 submeters are dedicated to measuring the electrical usage of individual circuits or specific loads within the panel. Secondly, the single main meter aggregates and measures the total electrical usage from all the submeters combined, providing a comprehensive overview of the entire system's consumption. The 400 amp panel itself is engineered to manage electrical currents up to a maximum of 400 amps, serving as a central distribution point for the electrical supply. The compatibility of an 8+1 metering system with a 400 amp panel hinges on several factors. The panel must possess sufficient physical space to accommodate the installation of both the submeters and the main meter. The wiring infrastructure within the panel must also have the necessary capacity to support the connections and communication requirements of all metering devices. It is imperative that the submeters and the main meter are installed correctly and connected to the panel in strict adherence to the manufacturer's instructions and all applicable electrical codes. The benefits derived from implementing an 8+1 metering configuration are multifaceted. It enables detailed monitoring of individual circuit and load usage, providing insights into specific areas of energy consumption. This granular data assists in identifying areas of high energy consumption, allowing for targeted energy conservation efforts. By pinpointing energy inefficiencies, the system facilitates energy conservation and cost savings through optimized usage and resource allocation. The data collected by the metering system provides valuable information for conducting energy audits, assessing overall energy performance, and identifying opportunities for improvement. The system can also be used for accurate billing purposes, particularly in multi-tenant environments where individual tenants are responsible for their energy consumption. Several considerations must be taken into account when implementing an 8+1 metering system. It is essential to verify that the panel has adequate physical space to house all the submeters and the main meter without causing overcrowding or compromising safety. Engaging a qualified electrician to perform the installation is crucial to ensure that the system is installed correctly, safely, and in compliance with all relevant electrical codes and regulations. Proper maintenance and periodic calibration of the metering system are necessary to maintain accuracy and reliability of readings over time. Calibration ensures that the meters are providing consistent and precise measurements, minimizing errors in data collection and billing. When evaluating the suitability of a 400 amp panel for an 8+1 metering configuration, a detailed assessment of the panel's capacity and physical layout is essential. The total load connected to the panel, including all circuits and equipment, should not exceed 80% of the panel's rated capacity of 400 amps, in accordance with the National Electrical Code, Section 220.87, which will ensure safe and reliable operation. The physical dimensions of the submeters and the main meter must be considered to determine if they can be accommodated within the panel's enclosure without obstructing access to other components or violating clearance requirements. The wiring infrastructure of the panel must be evaluated to ensure that it can support the additional connections required for the metering system. This includes assessing the size and number of conductors, the capacity of the branch circuits, and the availability of appropriate terminations and connectors. The submeters and main meter should be selected based on their accuracy, reliability, and compatibility with the panel and the intended application. Meters should meet industry standards for accuracy such as ANSI C12.20 and should be capable of providing the necessary data for monitoring and billing purposes. The installation of the metering system should be performed by a licensed electrician who is familiar with the relevant electrical codes and regulations. The electrician should follow the manufacturer's instructions for installation and ensure that all connections are made correctly and safely. The metering system should be properly grounded and protected against overcurrents to prevent damage to the equipment and ensure the safety of personnel. The metering system should be tested and calibrated after installation to verify that it is functioning correctly and providing accurate readings. The system should also be periodically inspected and maintained to ensure its continued accuracy and reliability. The data collected by the metering system should be regularly reviewed and analyzed to identify trends, detect anomalies, and optimize energy usage. This data can be used to identify areas where energy consumption can be reduced to improve the efficiency of equipment and to allocate costs fairly among tenants or departments. In addition to the technical considerations, there are also several practical considerations to keep in mind when implementing an 8+1 metering system. The cost of the metering system, including the meters, installation, and ongoing maintenance, should be carefully evaluated to ensure that it is justified by the expected benefit. The complexity of the metering system should be appropriate for the level of expertise of the personnel who will be responsible for operating and maintaining it. The privacy of tenants or departments should be protected when collecting and using data from the metering system. The data should be used only for legitimate purposes, such as monitoring energy usage and allocating costs, and should not be shared with unauthorized parties. By carefully considering all of these factors, it is possible to successfully implement an 8+1 metering system in a 400 amp panel and realize the many benefits that it offers. These benefits include improved energy efficiency, reduced energy costs, and more accurate billing. Let's delve deeper into the technical aspects and considerations for a successful 8+1 metering implementation in a 400 amp panel. Firstly, understanding the load calculations is paramount. Before adding any metering equipment, a comprehensive load calculation must be performed on the 400 amp panel to ensure that the existing load, plus the anticipated load of the metering system, does not exceed 80% of the panel's capacity. This is in accordance with NEC Section 220.87, which aims to prevent overloading and ensure safe operation. Secondly, consider the specific types of meters. Selecting the right meters is crucial for accuracy and reliability. Submeters should be chosen based on the type of loads they will be monitoring, such as lighting, HVAC, or general-purpose circuits. The main meter should be capable of accurately measuring the total current drawn by all submeters. Consider meters that comply with ANSI C12.20 standards for accuracy. Thirdly, the communication protocols matter. Modern metering systems often use communication protocols such as Modbus, BOSINET, or Ethernet to transmit data to a central monitoring system. Ensure that the submeters and main meter are compatible with the chosen communication protocol and that the panel has the necessary wiring and connections to support the communication network. Fourthly, current transformers are often needed. For larger loads, current transformers, abbreviated CT, are used to reduce the current flowing through the meter to a safe and measurable level. The CT should be properly sized for the expected current range of the circuits they will be monitoring. Ensure that the CT are installed correctly and that the meter is configured to use the correct CT ratio. Fifthly, examine the wiring and conduit requirements. The wiring and conduit used for the metering system must comply with all applicable electrical codes and regulations. Use appropriately sized conductors for the current they will be carrying and protect them with conduit to prevent physical damage. Ensure that the wiring is properly grounded to prevent electrical hazards. Sixthly, look at the panel layout and space. The physical layout of the panel is a critical consideration. The submeters and main meter must be installed in a location where they are easily accessible for maintenance and testing. Ensure that there is sufficient space within the panel to accommodate all of the metering equipment without overcrowding or obstructing access to other components. Seventhly, understand overcurrent protection. The metering system must be protected against overcurrents to prevent damage to the equipment and ensure the safety of personnel. Use appropriately sized circuit breakers or fuses to protect the metering circuits. Ensure that the overcurrent protection devices are installed in accordance with the manufacturer's instructions and all applicable electrical codes. Eighthly, grounding and bonding are key. Proper grounding and bonding are essential for preventing electrical shock hazards and ensuring the proper operation of the metering system. Ground all metallic enclosures and equipment to a common grounding point. Use bonding jumpers to connect all metallic parts of the system together. Ninthly, testing and commissioning is important. After the metering system has been installed, it should be thoroughly tested and commissioned to verify that it is functioning correctly. Use a calibrated meter to measure the current and voltage at various points in the system. Compare the measured values to the values displayed by the meters to verify their accuracy. 10thly, documentation is essential. Maintain detailed documentation of the metering system, including wiring diagrams, equipment specifications, and test results. This documentation will be invaluable for troubleshooting problems and performing maintenance in the future. Lastly, regular maintenance is important. Regular maintenance is essential for ensuring the continued accuracy and reliability of the metering system. Inspect the meters and wiring regularly for signs of damage or wear. Calibrate the meters periodically to ensure that they are providing accurate readings. By following these technical guidelines and considerations, it is possible to successfully implement an 8+1 metering system in a 400 amp panel and realize the many benefits that it offers. Remember that safety is paramount when working with electricity. Always to energize circuits before working on them and follow all applicable electrical codes and regulations. Engage a qualified electrician to perform the installation and ensure compliance with electrical codes. Furthermore, the installation must adhere strictly to the National Electrical Code, or NEC. Several articles within the NEC are particularly relevant to metering installations. Firstly, NEC Article 220 covers branch circuit, feeder, and service calculations, ensuring that the electrical system is adequately sized for the anticipated load. Secondly, NEC Article 250 addresses grounding and bonding, which is crucial for safety and preventing electrical shock hazards. Thirdly, NEC Article 310 provides requirements for conductors for general wiring, including ampacity, insulation, and installation methods. Fourthly, NEC Article 312 covers cabinets, cutout boxes, and meter socket enclosures, specifying requirements for installation and construction. Fifthly, NEC Article 408 pertains to switchboards and panel boards, including requirements for overcurrent protection and labeling. Lastly, NEC Article 725 addresses Class 1, Class 2, and Class 3 remote control, signaling, and power-limited circuits, which may be relevant for communication circuits in the metering system. When installing an 8+1 metering system in a 400 amp panel, it is essential to select components that are listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories, abbreviated UL, or Electrical Testing Laboratories, abbreviated ETL. This ensures that the components have been tested and meet safety standards. The metering equipment should be installed in accordance with the manufacturer's instructions and all applicable electrical codes. The installation should be performed by a licensed electrician who is familiar with the NEC and local electrical codes. Proper grounding and bonding are essential for preventing electrical shock hazards. All metallic enclosures and equipment should be grounded to a common grounding point. Bonding jumpers should be used to connect all metallic parts of the system together. Overcurrent protection should be provided for all metering circuits. Circuit breakers or fuses should be sized appropriately for the expected current and installed in accordance with the manufacturer's instructions and the NEC. The metering system should be tested and calibrated after installation to verify that it is functioning correctly. A calibrated meter should be used to measure the current and voltage at various points in the system. The measured values should be compared to the values displayed by the meters to verify their accuracy. Regular maintenance is essential for ensuring the continued accuracy and reliability of the metering system. The meters and wiring should be inspected regularly for signs of damage or wear. The meters should be calibrated periodically to ensure that they are providing accurate readings. Consider the environmental conditions in which the metering system will be operating. If the panel is located in a damp or corrosive environment, use equipment that is rated for those conditions. Protect the metering equipment from physical damage by installing it in a secure enclosure. Provide adequate ventilation to prevent overheating. In addition to these technical and safety considerations, there are also some practical considerations to keep in mind. The cost of the metering system should be carefully evaluated to ensure that it is justified by the expected benefits. The complexity of the metering system should be appropriate for the level of expertise of the personnel who will be responsible for operating and maintaining it. The privacy of tenants or departments should be protected when collecting and using data from the metering system. The data should be used only for legitimate purposes such as monitoring energy usage and allocating costs, and should not be shared with unauthorized parties. By carefully considering all of these factors, it is possible to successfully implement an 8+1 metering system in a 400 amp panel and realize the many benefits that it offers. These benefits include improved energy efficiency, reduced energy costs, and more accurate billing. A properly designed and installed metering system can provide valuable insights into energy usage patterns, allowing for better management of energy resources and reduced operating costs. Remember that working with electricity can be dangerous. Always take precautions to protect yourself from electrical shock hazard. If you are not comfortable working with electricity, hire a qualified electrician to perform the installation.